Hey scholars, this week we are going to learn about numbers that are positive and negative and explore the meaning of them in real-world contexts. So we're going to start off by reading the first page of the notes and highlighting important terms, and then do some practice problems about integers. So let's start reading. Positive numbers are numbers that are greater than 0. Negative numbers are numbers that are less than 0. The meaning of a negative number in a context depends on the meaning of 0 in that context. That's an important sentence, so I'm going to highlight that in my notes on the screen because we want to make sure we always know what 0 means when describing a situation. So here's our first example. Say we have a thermometer. If we measure temperature in degrees Celsius, then 0 degrees corresponds to the temperature at which water freezes. So I'm going to look at this thermometer on the right, point to the 0, and label that as my freezing point, because we're going to use that freezing point to help us describe what the other numbers mean. In this context, positive temperatures are warmer than the freezing point, and negative temperatures are colder than the freezing point. So I'm going to label here that these numbers right here above are warmer, and these numbers over here are colder. A temperature of -6 degrees Celsius means that it is 6 degrees away from 0 and it is less than 0. And as you can see here, this thermometer shows a temperature of -6 degrees Celsius. So that's an example we have now of a thermometer. Let's explore an example with sea level. So I'm going to scroll down here to this next example that is also important with knowing what 0 means. So another example is elevation, which is a distance above or below sea level. An elevation of 0 refers to the sea level. So I'm going to label that on my graph here that this point 0 is sea level. And positive elevations are higher than sea level, and negative elevations are lower than sea level. So in this diagram, if you were to just describe the situation here, you can see that the bird and the dolphin are above sea level in the diagram, have positive elevations, and then the shark and the octopus are below sea level and have negative elevations. So what we're going to do next is we're going to explore an example where we're going to look at some thermometers and describe the temperature of them by reading the stories for each one. So turn to the back of your first page for the first example. Here, we're going to read 3 situations involving changes in temperature and 3 number lines. And all number lines are vertical, so all numbers that are higher are going to be positive, and all the numbers that are lower are going to be negative. So I'm going to model the first example, how I'm going to find the answer to the question, and then you are going to do number 2 and number 3 by yourself. Here's our first example we're going to read. It says the following. At noon, the temperature was 5 degrees Celsius. So I look here and I see that we're starting at 5 degrees Celsius. By late afternoon, it rises 6 degrees Celsius. So I'm going to highlight rise 6, so I know that's important. And it's asking me, what would the temperature be late in the afternoon? So let's annotate the first thermometer on our page to represent a situation here. I'm going to first start by labeling 5 degrees Celsius on my page. So I'm going to go to the thermometer and count up 5. So 1, 2, 3, 4, 5, and label that as 5 degrees Celsius. I also saw that by the afternoon, the temperature rises 6 degrees. I know that rising means it's going to become bigger, and we know that going up is positive. So I'm going to count up 6 units from 5. 1, 2, 3, 4, 5, 6. And I'm going to label that with an arrow going up and writing the number +6 because we're rising by 6. And now it's asking us what number or what temperature are we at late in the afternoon. So the math problem that we're going to solve is we started at 5 and we're adding 6 degrees. And we can use our number line to help us find out what it is. And I can count up from 5. So 5 moving up 6 units would be 6, 7, 8, 9, 10, 11. So we're ending at 11 degrees Celsius, which makes sense because 5 plus 6 is 11. So to recap the steps I modeled, I labeled where we started. I drew an arrow in the direction that we're moving, whether we're rising or we're decreasing. And I count how far we are to the next number to find our final answer. I'm going to read B, and then you're going to do it by yourself, and then continue the video whenever you want to check your answer. B says the following. The temperature was 8 degrees Celsius at midnight. By dawn, it has dropped 12 degrees. What was the temperature at dawn? With what I highlighted, I want you now to pause the video and think to yourself, how can I model a temperature of 8 degrees dropping by 12 to find out my new temperature? Pause here and then continue when you're done with the problem. Here is what you should have drawn for the second thermometer. You should have labeled 8 degrees, 8 units above 0. You should have counted 12 units down because the temperature is dropping. So you should have counted 12 times down the number line. And then your final answer should be -4 because compared to the 0 on a thermometer, you are 4 units below the 0 level. Therefore, 8 minus 12 gives you -4. Let's try the last one. I'm going to read it again and you're going to do it on your own. Here's what the problem says. Water freezes at 0 degrees Celsius, but the freezing temperature can be lowered by adding salt to the water. A student discovered that adding half a cup of salt to a gallon of water lowers its freezing temperature by 7 degrees Celsius. What is the freezing temperature of a gallon of salt water? Again, follow the steps of labeling where you're starting, counting how many units you're moving up or down based on the context of the problem, and then deciding where you're ending to determine the final temperature. Pause here and continue whenever you have finished the problem. Your final answer should be -7. You started at 0 on a thermometer at freezing point. You went down 7 units by counting, and you landed on -7, which is 7 units below the 0. We are now going to explore an example with the other situation, which is elevation. So let's turn to the next page to do our next question. I'm going to model this question here in full, and then you'll do the back page on your own for practice. So in this situation here, we have a table that shows elevation of various cities: Harrisburg, Bethel, Denver, Coachella, Death Valley, New York City, and Miami. So to help me see what's going on here, I'm going to draw a diagram first of what I see as my elevations to list them from highest to lowest. I'm going to draw a line next to my table and label it 0, and that's my sea level. And I'm going to list the other heights, elevations, above and below based on the number. I see that Denver is the tallest one at 5,280. So I'm going to write that at the top of my little chart here to rank my elevations. My next highest number I see is 1,211. Then I see 320. And then I see 33. So those are my 4 positive elevations ranked from highest to lowest. And then I have 0 for my sea level. And I see I have 2 negative elevations. Negative 22 is closer to 0. It's only 22 units away. So I'm going to put that next, negative 22. And then my lowest elevation is negative 282. That is much further away from 0 than negative 22. So having my annotation here on the side will help me answer my questions regarding the situation. So let's look at these questions one at a time and answer them with complete sentences. It asks, on the list of cities, which city has the second highest elevation? So using my annotations, I see that the second highest elevation is 1,211, which corresponds to Bethel, Indiana. So I'm going to say the answer here is Bethel, Indiana. My next question says, how would you describe the elevation of Coachella, California in relation to sea level? I see in my chart that Coachella is negative 22. And I know that negative sign means below the sea level. So I'm going to describe it as the following. Coachella is 22 feet, making sure I have my units, below, keyword here is below, sea level. That word below describes how the elevation is negative. My next question says, how would you describe the elevation of Death Valley, California in relation to sea level? Again, look at my table and I see that Death Valley says negative 282. That negative sign means below the sea level. So to capture that thought, I'm going to write Death Valley is 282 feet below, again the keyword here, below sea level. Now, my last question says, how would you describe the elevation of Miami, Florida? I see that Miami, Florida says 0, which means that it's not above or below sea level, it's right at sea level. I'm going to write that. I'm going to write that Miami is at sea level. So steps I took were the following. I drew a diagram to list the elevations from highest to lowest to help me see a visual, and I used that diagram that I drew to help me answer my questions about the cities and their elevations. So you will now do the similar thing for the last example on your own. I'm going to scroll there so you can see what is it about. On the back of your notes today, you have two tables. One about mountains and one about trenches. Trenches are valleys within the ocean that are deep in the ocean. You're going to do the same thing. We're going to draw a diagram to help you list them from highest to lowest relative to sea level, and use your diagram to help you answer the 3 questions below. When you are finished, well, first off, pause here, and then when you are finished, you can continue the video to check your answers for A, B, and C. Here are the answers for A, B, and C. The Mariana Trench is the lowest in the world at 11,033 meters below sea level for letter A. For letter B, 0 represents the sea level, and points above 0 are above sea level, points below 0 are below sea level. And then for C, it's asking you which is further, the deepest point in the ocean or top of the highest mountain. The deepest point is further away from sea level because 11,033 is greater in value than 8,848. Ask any questions you have now before you take your X ticket on today's lesson.